Wait a second, guys. Yeah. So we have done already 2D analysis and 3D analysis. Today we will go for the 1D analysis. So I think that 1D analysis. I already tell you what is the difference between 1D, 2D, and 3D. 1D means it is very much bigger than, like you can say, as a negligible width and height you can find for the object. Those analysis we have to do under 1D analysis. The next one is 2D analysis. 2D analysis will do when the length and width is very much bigger than the third dimension. That is, we can say as an example, all the sheet metal components we can take, or we can take plastic components. Those components we have to do 2D analysis. 3D analysis means the component which has similar dimensions, like length is similar to width is similar to height. So in that case, we have to go for the 3D analysis. So what are the components we are using in 3D? Like for which components we are doing? Like for example, casting components. Casting, forging components, we are preferring the 3D analysis. When you go for the plastic components, or we go for sheet metal components, for that one we have to go for 2D analysis. Usually we will do when we have the simple components, like beams, are there, or we can say rods. For those kind of objects, we are performing the 1D analysis. Okay. Yeah. Now see here, I am taking the static structural so that I can perform. Yeah, this one I will do here. Like this geometry also will create under Ansys software only. Nothing is there simple, only the procedure is same only for every analyzer. I already said to you. Just we have to assign the boundary conditions in different. Okay, now see here I am taking the static structural analysis. Okay, and it's mentioned the material here as 2.13 into 10 to the power of 11 Pascal and Poisson's ratio as 0.3. These two values we have to specify, so go for engineering data, the duplicate of this one and click the link, then change the Young's modulus to 2.13. 3 Pascal. Poisson's ratio is okay. So I assign the properties here. Just to close this one, now go for design modeler. Okay, now we have to create the geometry. Nothing is there, just we have to create this one. That's it. Okay. I will create one sketch on this plane. Okay. Now see here, I will create the geometry here. If there is create this one, this one, this one, this one, this that's create here. For that one, take a line. This line, okay. Then this line can create. this line is working line for this okay. Now here we have one vertical line. Just first of all, let us use the demonstrators. For constraint, make vertical. Okay, it's like vertical. Anything else here? Constraint will use the number of dimensions. Dimensions, we have to figure out the distance between this point and this point is shown as 3 and those dimensions will be this point. So here, whatever you are entering, it also is constraint, make this one vertical, not specific. This value is 3 meters per centimeters. Okay, now see here I got complete sketch. Now see here guys, our sketch got completed here. Now go for modeling. So what you have to do, you have to convert this one to go for concept lines from sketches. Apply. Remember one thing, this should be a line body. Whenever you're performing the whenever you're performing the 1D analysis now. So at that time, remember the body should be in a line body. Initially it was not there. For example, if I delete this line body, you cannot find any body else. Only you can find sketch. So with the help of sketch, okay. Guys, wait a second. See here guys, so go for concept lines from sketches, or we can take lines from points also, like we can select individual points here and we can make that one. But why should I make that? What I will do, directly will go for line from sketches, select the sketch. Now see here I have the line body. Is it there? Check. Okay, now you can hide your sketch. Now see here, this is my line body. See here, line body. Suppose for example, I will show you what happened when we go for sketch or when we go for line body. See here, if you go for line bodies, from here onwards, like if you select this line body, here we can able to specify the cross section. But whereas when you select this sketch, you cannot find any option for selecting the cross section. Why? Because for every 1D analysis, whenever you are performing, it's just a line. We don't have any solid body. So analysis we will do only on solid body. So what we will do to this line body, we will assign the cross sections. Okay, we'll specify the cross sections here. So in that case, what we have to do means we have to see here, it's mentioned the cross sections also, like it is a pipe with the inner radius as 25 mm and outer radius as 35 mm. Okay, these two options we can like two values is mentioned. So in that case, what we have to do means first you have to create the line body with the 3D line bodies. So go for line body. Here we require the cross section, but still I didn't create any cross sections here, so I cannot able to select here anything. If you go for here drop down also, you cannot find anything showing like none. Why? Because I didn't create any cross section here. So before going for the line bodies, what you have to do, you have to go for creating the cross section. So in concept only you can find the below side cross sections. What cross section you want? You want a circular tube. See here in our problems mentioned like circular tube. So go for circular tube from here, concept, cross section and circular tube. Here you have to specify inner diameter and outer diameter. I have changed the unit system to mm, and inner diameter mentioned as 25 mm. See, nothing is, we have not, like, we don't want to do anything on the screen. Everything is in your detail view. From here only you have to change the values. So outer diameter I am giving, outer radius I am giving like 30. Yeah, outer radius as 30 and inner radius as 25. 30 mm, sorry, 35 mm, 25 mm and 35 mm. This we have to specify, like 25 mm and 35 mm. After specifying the value, just click on generate. So see here your cross section also generated here. Now again go for line properties. Now we can able to see that thing, circular tube. So automatically it will be placed here. So select this one, generate. Now see here what happened. When you go to slide body, once again you can find the cross section has been assigned to your body, but when you go to the body you cannot find the thing. See, you cannot able to see that tube here, like whatever we specify the cross section, it is not visible here. So how to see that option, like how to see that pipe here on this? So in that case what we have to do, go for the view option. Here you can find cross section solid. If you enable this one, right now you can able to see the pipe. You are not able to see right now, you can able to see the pipe has been properly assigned to that cross section. Don't want to see, go for view, disable. You cannot able to see that cross section. So like that we can able to create the job. Okay, like that we can create the cross section for the 1D geometries. Now close the geometry. Now go for the models. Now we have to specify the boundary conditions. So go for model. Select the model. Then wait a second, guys, I'm waiting for the call. Yeah, sorry guys. Guys, are you able to hear me?
Yes, sir.
Hello?
Yes, sir.
Yeah. Now see here guys, I created the geometry and I entered into the model environment. Now here also you cannot able to see that thing. When you go to geometry you can find the line body, but the cross section you cannot able to see here. Even if you enable there also you cannot able to see directly here. So if you want to see the geometry here, what you have to do means, sorry, the cross section, again here also you have to go for view. Here you can find cross section solid geometry. If you enable this one, then only you can able to see the cross section geometry. Understand? View, cross-section surface. Understand? Okay. Now see here, the next thing is generate the mesh. Geometry also, like coordinate system also we'll check here. X-axis is here, okay. Y-axis, because we require the axis, we can say there. Fine. Now what I will do, I will go for the mesh generation. Right click. If any properties are there given for mesh, solve the following frame as shown in figure. Find total deformation, number EF individual displacement value, will generate normal mesh only. We'll see how the mesh is coming. If it requires, it's normal. You don't require that much. If you want means we can make somewhat precise mesh. Here that was only we are getting. Okay. Now we have to specify the boundary conditions. Carefully see here, guys. Here at this point, like at point A and point F, at point A and point F, it is a fixed support. Okay, it is a fixed support. Those 2 points we have to specify the fixed support. So here this point and F. So what I will do, first of all, I will hide this thing. First I will specify the point. So right click, insert, fixed support. So I want at this point as a fixed support. Here I want the fixed support. Apply. Separately you have to take. Then right click, insert, fixed support. At those 2 points we require the fixed support. Now after that one, at this point is assigning 12,000 newtons, and at this point assigning 10,000. Okay. So go for force. Newtons means force only. So right click, insert, force. At this point, apply. Take always component. Why? Because it is showing the downward direction. So you have to take as a component, and in Z axis direction you have to specify. Downward direction means negative 12,000. Okay. So go for component here. Y-axis direction, negative 12,000. Okay. Again go for right click, insert, force. At this point, apply vector, no vector, component here. Here also y-axis direction. The value is 10,000. It's in down direction means negative 10,000. Now see here, forces are assigned here, supports are assigned here. Now what we have to do? We have to check the results. Just click on solve. Yeah, it gets solved here. Now we'll check the results. What are the results we require? Here it mentioned like the first thing is total deformations we have to find here. Okay, total deformation. Yeah. Right click, insert, deformation, total. Then right click, insert. I want here force reaction. I am checking here force reaction. Okay, force reaction where you want to find. I want to find the force reaction. See here, force reaction. What is force reaction means? See here, where you are assigning the force at this point and at this point. These 2 points you are specifying the force. So after specifying force at those particular location, what will be the reaction? Means how the object is behaving at that particular point. So those reactions we have to find by using this force reaction. I want to find the force reaction between those at those 2 points also. So in that case, what I will do, I will go for force reaction for fixed support one, not fixed support one. Yeah, fixed support one, and I want to find the fourth reaction. Right click, insert for the fixed support 2 also. For those 2 fixed supports, we have to find the fourth reaction. This one is not because anyhow we will find the spaces here. So click on solve. Now see here, the total deformation I am getting under the load. Okay, under the load, the total deformation we are getting is 0.89. 0.89352 is the maximum deformation I am getting, and that is also at this location. Here now. At this location, I am getting the maximum deformation. Why? Because even if I specify the force here, but this one I have this support, this support, this support. That's why it is not getting that much deformed. Here we don't have any support for that one. Okay, so here we don't have that much support for this geometry. That is the reason what happened here. It is getting maximum deformation. The next one is axial force. Okay, so maximum axial force means combination of when we assign the force, at what point the maximum force is getting there, at what axis. So here I am getting at this location, that is 10,585 maximum axial force I am getting here. Force reaction. How much force reaction? So here, how much force reaction I am getting at fixed support 1 here. Right? After see here I am specifying 2 different forces. One is something like 12,000 newtons and 10,000 newtons. So both the forces we are specifying here. So when we are specifying these 2 forces, how much force is reacting on this fixed support and how much force is reacting on this support. These 2 things. So these 2 things we have to find. So for example, for fixed support 1, how much force reaction is getting, means how much force is applying on this fixed support. Here I am getting around total is 10,564 newtons force I am getting on this fixed support 1, and on fixed support 2 I am getting here like 30,410. Okay, understand guys? See, when we are specifying these 2 force on these 2 particular locations, so what happened here? So the maximum force reaction at point fixed support 1, how much we are getting? 10,000 newtons, and maximum force reaction at fixed support 2, I am getting like 30,410 newtons. Okay, that much force I am force reaction I am getting on those fixed supports. Understand, guys? Any doubts in this one? In 1D analysis? Sure,
No, sir.
like no doubts now. Remaining guys.
No, sir. No, sir. No, sir.
So this is your 1D analysis. Like that only we have to. Okay, shall I tell you one more problem in that one?
Yes, sir.
Can you able to do this one? Nothing is there here. One fixed support is there, one simply support is there. Okay, and at these 3 points you have to specify the loads. Here you have to specify 30 newtons, and here you have to specify 15 newtons, and here you have to specify 25. So like that we have to specify the things. I think is this all the following frame as shown in figure. Okay, find the total deformation due to loads on frame, means due to this load what are the total deformation. And here what you have to do means you have to take two cases. One is beam, another one is pipe. Two positions you have to take, not in a single problem, different. Okay, one thing is you have to take as a beam, the other one is pipe. Those two positions you have to take. And the material will remain same. At point D, load 25 newtons acting towards the BD member, means it is coming in this direction only. Okay, nothing is this much. So like that you have to specify the loads, then you have to find the deformations. What are the deformations you are getting for individual frames, right? Here how much deformation you are getting, here how much deformation you are getting, here how much load it is. This one also we can able to do here. Go for deformation. I want to find the total deformation here. One more option you can find here, that is okay, total deformation. See here till now we checked in 2D, 3D, and here also we check the total deformation. Then the one more thing is that is your okay. Here we have one more option, that is directional deformation. So what is this directional deformation? So see here guys, directional deformation means suppose if you assign any force to the body, okay, then in a particular direction how much deformation is. See here this deformation will come under both in x-axis and y-axis right now. See here this deformation is coming here both in x-axis and y. See it is moving in horizontal as well as vertical also. So in two direction it is showing like deformation. So for example, if I want to see only deformation only in one direction, means you have to go for the option directional deformation. Under see just select the just select the deformation option here. Under that one you can find the directional deformation. Like in this, in which direction you want to find the deformation. Okay, I want to find in x-axis direction how much deformation is. See previously we are getting 0.89. Now if you go for this one, solve. Here I am getting in x-axis I am getting 0.60. Okay, it is showing in like here in animation it is showing like it is moving in xy direction, but when you check the value here it is showing 0.60 in x-axis direction. If you go for y-axis direction, solve. In y-axis direction, we are getting only 0.17 mm deformation in y-axis direction because of this support here. In y-axis, we have support now. That's the reason it's getting much less deformation we can find in y-axis direction. So like that, we can find the directional deformations also. Okay, understand this one?
Yes, sir.
Any doubt, guys?
No, sir.
Yeah. Now see here, guys. I am taking this 8th problem. Why I am taking this one means, see here till now, here also you have to find total deformations. Here also you have to find total deformations. Like results we have same only, but here some more things we are checking. That is your shear force, bending moment, and bending moment diagrams. We'll check this. See here, guys. These things you already know. Like in your engineering second year strength of material subject is there. There you have learned these things. Shear force, bending bending moment diagram also you created. The same thing in software also we can able to do. Okay, same thing we are doing in software also. So for that reason, what I will do is okay. Same material will take here. I am going for static structural. I will take this material only. Okay, now go for geometry. This also you have to do 1D only. Why? Because see here, whenever you can find the bending moment diagram, so in that case you have to create 1D and you have to perform 1D analysis. Why? Because for 3D analysis, for 2D analysis, you cannot able to create the bending moment diagrams. Okay. Now I have to create only one line required here. That's it. Single line required here. So go for the sketch on display. Create one line. The length is 2 meters, 3 meters, 2 meters. Okay, guys, remember one thing here. What you have to do, you have to create 3 separate lines. Three separate lines you have to create so that we can able to create. We will get the points here at the time. Okay, that is the reason what you have to do. 3 lines I will create. One is 2, 3. Here this one I am leaving like dimensions. First one is 2 meters. Second one is okay. Now see here the lines has been created here. Now go for modeling. Now go for concept, create lines. Remember one thing, always create lines. This line, line. Generate. Then again go for concept, line from points by pressing control, this point select, this point select, generate concept lines. Okay. What I will do means we have the line body. I will create one cross section concept cross section. Here we have the cross section as rectangle 50 mm. So go for concept cross section rectangle. Here we required meters. Okay, generate the cross sections. Now see the cross section generated. Now go for line body, select this cross section. Now see it has been generated. We'll check whether it's generated or not. Go to position solid. The cross section has been assigned to the work. Okay. Now see our geometry has been created. So close this one. Go for model environment. Go for model. Now we have to specify the boundary conditions here. Check the line body here. Square. Check the cross sections also. Square cross section also. Now coordinate system x, y, z, x, y, z. Now generate the mesh. The mesh need property function here. Now it's not function, so go to IP. Mesh. So mesh also has been generated. We'll check the quality of mesh. What I will do, I will specify the boundary conditions now. What are the requirements are there? Here we have fixed support, here we have simply support. So I'm going for the fixed support at this point. This is my fixed support. The other side I want here simply support at this point. Because here we have fixed support, we have simply support. Now we have to specify the forces, which is mentioned like 50 Newton at this point and 30 Newtons, 30 kilonewtons and 50 kilonewtons. I already created the thing with it. Right now you can understand why I created those three as a different. Why? Because we require these points to assign the forces. Now go for force 1, which is at this point apply downward direction 50,000 newtons. Downward direction 1,000 newtons. Insert force at this point, apply component. Other one is 30,000. So same minus 30,000 newtons. Now see here, forces has been assigned here. Now click on solve. It is saying that the deformation is very large compared to the model quantity. Like we are getting very big deformations here due to the forces which we are specifying. Okay. So what I will do now, I will check the results. What are the results we have to find here? First one is shear force. So right click, insert. Here we can find shear force. We can find here. So go for shear force. Okay. Now the next thing is right click. What is asked to find here? Bending moment diagram. So right click, insert, result, shear moment diagram. Bending moment also we have to find, and bending moment diagram also. Okay. Path we have to have to specify the path difference. For the construction job. So location the path I given here. I think if you guys just click on this model here, you can find construction job. It means we required one job. Okay, they required one construction geometry. By clicking the geometry, under that one, if you create construction geometry here, right click here, insert. Here you can find the option path. Click on that path. Then after getting the path, it will ask you to specify the starting point and ending point of the path. 2 points specifies automatically it will generate the path. Okay, after generating the path, now go for rotation. Go to diagram path. Here I can take here the path which we created at the top. I want for which line you require. You can select here. Right. Okay. Now uh, go for all body. I will go for all bodies. So, body is shown in the diagram. I want for the path. Apply. Now click on submit. Just say here the shear moment doesn't amount to this path above the dimensions. Actually, the deformation is large compared to the model boundary box. Verified boundary conditions are considered for the large deformation. Large, actually, the thing is here, the the bar size is the So what I will do is I will change the geometry so that we can able to find the results. Actually, the thing is, guys, like if you make a shape diagram, you make a path, and here we have can able to select the path, but it's not. Okay, guys, we can do one thing. I will change the geometry properties here. It's